Hello everyone, I am Jitendra Rao, 8th semester student studying in Sri Venkateswara College of Engineering. I am hereby presenting technical seminar on the topic using artificial intelligence to visualize the impacts of climate change. This seminar is conducted under the guidance of Manjunath H, who is working as assistant professor in the Department of Electronic and Communication Engineering. These are the contents for the presentation. The first slide includes introduction. The second slide includes literature survey. Further slide includes methodology, block diagram, and applications. Then we have result, conclusion, and finally references. Introduction. Climate change is one of the most pressing issues of our time, and it is crucial that we find innovative ways to understand and communicate its impacts. While AI can help us understand the complex issue of climate change, AI offers a powerful tool to understand and communicate the impacts of climate change, which is one of the most pressing issues of our time. GAN, Generative Adversarial Networks, can enhance climate visualization by improving data analysis, creating dynamic and personalized visualizations for different audiences. As AI has the potential to improve data processing, produce more dynamic and interactive visualizations, and allows us for customized visualizations for various audiences. Large-scale, complicated climate data, interdisciplinary collaboration, and moral issues in AI/ML applications are some of the difficulties in displaying climate data. As As we can see from the structural diagram, artificial intelligence is interconnected with several different system and languages and a few networks as well. There are some examples of AI or ML applications for climate visualization include simulating how the climate change would affect coastal flooding and using generative AI to produce fresh visuals for climate data. As we further move ahead, the research and innovation in GANs for the climate visualization as well as the need of making climate data and visualizations available to a wide range of stakeholders, as it includes generating new visual representation of climate data using generative AI and simulating the effects of climate change on coastal flooding. Making the climate data and visualization accessible to a wide range of stakeholders is very crucial to emphasize the importance of interdisciplinary collaboration. Moving further, these are the different papers we have referred for the literature survey. The first paper, the first paper, after going through the first paper, we have noticed that the paper has certain pros and cons. The first paper pros are that the AI can improve healthcare, transportation, and education, leading to better quality of life. And ethical considerations in AI development can promote well-being and human interest. As regarding the cons, the lack of regulation and oversight in AI develop can lead to unintended consequences. The second paper pros are it provides insights into the psychological factors that shape our attitudes and behaviors towards the environment, and the biases that hinder environmental action include the belief that individual actions are inconsequential. As the cons are it oversimplify the complexity of the environmental challenges we face. The third paper pros are ML can enhance climate models and predictions by identifying patterns and trends in complex climate data. ML can help identify optimal renewable energy implementation areas and optimize energy consumption. The cons are as climate data is often incomplete or limited, which can lead to bias or inaccurate models. The cons after after referring the fourth paper, the pros are this study provides insights for urban planning and infrastructure decisions with regard to future climate changes, and using contemporary climate analogs makes future climate projections more relatable and understandable. The cons are projections rely on assumptions and model outputs, leading to potential inaccuracies in results. From the fifth paper, the pros are the use of spatially adaptive normalization allows for more flexible and precise control over image synthesis. And the model is able to generate high quality images with realistic and diverse variations. The cons are model training requires significant data and computation resources, leading to time and cost requirements. And the final paper pros are the potential of climate imaginary is engaging and educating the public about climate change. The second point is digital platforms and social media can increase the reach and impact of climate imaginary for broader public engagement. Cons are they restricted to a small number of demographic groups and might not be transferable to a larger population. In the methodology, we can see from the we can see from the diagrams that the climate changes are being done through social adaptations, such that framework is created that combines AI and climate modeling to generate visualization of climate change impacts using various data sources such as climate model, output data, and satellite data. Further applying machine learning algorithms such as convolutional neural networks and generative adversarial networks for generating the visualizations. As we have used uh, generative adversarial networks for the project. The block diagram further states that how the climate change prediction is done through tracking AI. As we can see from the diagram, uh, the data is collected from the satellite and it tracks through JAN's network. The examples of the visualizations generated using the framework, such as maps of sea level rise and changes in vegetation. As the developing of the interactive visualization tool helps in generating realistic, high quality images, below is the example of an urban flooded scene generated by a generative model. The JAN algorithms can help with climate model calibration and provides improving the accuracy of climate models. The need for interdisciplinary collaboration between climate scientists and machine learning experts provide the example of before and after using JANs. So figure 5 shows before and after example of transformation carried out by a JAN approach based on an image of a suburban house. Figure 6 is before and after flooded scene from Unity simulated work. The Unity simulated world is created using Unity 3D software. The use of uncertainty quantification techniques to improve the interpretability of the visualizations is done. Further future is research directions for using AI to improve climate change visualization include developing interactive tools and improving the accuracy of climate models. The applications are it predicts forecast for extreme weather events caused by climate change, assists farmer in adaptation of climate change and managing crop yields by predicting changes in temperature, rainfall pattern, and other climate variables. Ensures determining optimal locations for renewable energy projects such as wind or solar farms by using climate and environmental data. It predicts how climate change will affect disaster-prone areas and assist in the planning of disaster response and relief efforts. It ensures to manage and monitor water resources like groundwater levels, water quality, and river flows, which can be affected by climate change. The support It supports the conservation of endangered species by monitoring and managing wildlife habitats, which may be impacted by climate change. Predicts climate change effects on urban areas like flooding, heat waves, and air pollution, aiding in infrastructure development and urban planning. It ensures to monitor and predict the spread of climate change affected diseases transmitted through vectors. It predicts disaster response by providing real-time situational awareness during natural disasters, such as hurricanes, wildlife, wildfires, and floods, to facilitate rescue and faster recovery efforts. Moving on to the results, we discussed the use of AI in visualizing the climate change impacts. The proposed framework combines AI and climate modeling for generating visualizations. The visualizations can help policymakers and the public understand the potential effects of climate change. The data sources and techniques used include AI algorithms and climate models. The algorithm, such as JANS, is used to collect limited realistic data and provides high definition images of flooded areas through the datasheet we collected. In order to address the lack of before and after flood data, we created a simulated world using the Unity 3D game engine that we could use to generate realistic image. As you can see from the figure 7 below, it is a screenshot of the website that will host our AI climate impact visualizer. The challenges involved in developing this visualization are data complexity and the need for high performance computing. Future research directions include improving the accuracy of climate models and developing interactive visualization tools. In the conclusion, climate change is a complex and global issue with significant impact on human society. Visualization, the impacts of climate change using AI can help make it more tangible and facilitate public understanding and action. AI can be used to predict and simulate further climate scenarios, allowing us to better understand the potential consequences of different action or inaction. Visualization tools can help policymakers and the public better comprehend the scale and urgency of the climate crisis, such as hurricanes, flood, or maybe eruption of lava. Developing an immersive website to allow users to visualize the potential futures and take action to slow down climate change. The potential impact of AI visualization tools on public opinion and action towards mitigating climate change is significant and should be further explored. These are the reference papers we have used. Thank you.